How'd you like to listen to .NET Rocks with no ads? Easy. Become a patron. For just $5 a month, you get access to a private RSS feed where all the shows have no ads. $20 a month will get you that and a special .NET Rocks patron mug. Sign up now at patreon.netrocks.com. Hey, welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
Steve Smith is with us. We'll be talking to him in a minute. But hey, man, how are you doing? I haven't talked to you in a while.
We had a burst of shows, and now we've, caught back up. So it's time to get back to work again. And I happen to be in Mexico. So coming to you from the Grand Lux at the Vedanta Resort.
How's your bandwidth?
Good enough. Everybody else is at the pool, because they're on vacation.
Yeah. Right.
So hopefully it holds together. But I'm recording locally. We'll be okay.
All right, good. Well, let's start things off the right way with Better Know Framework.
All right, man, what do you got?
All right, well, Google is at it again.
Yes, they are.
They now have this Google DeepMind, their AI thing.
Yeah, the original AI guys.
Yeah.
The reason that OpenAI was made.
Yeah, so they have this Genie team, and they came out with Genie, which is a generative, interactive environment creator.
So no wishes?
Yeah. And you can't wish for more wishes.
Okay.
So we introduced Genie, a foundation world model trained from internet videos that can generate an endless variety of playable, action-controllable worlds from synthetic images, photographs, and even sketches. So the idea is that you can sketch some things or find some things or just say, give me something that looks like this, and you can make side-scrolling games, like Mario Brothers kind of thing.
Awesome.
From them automatically. At least that's what I think it is. I haven't done it. And it looks like the only application is sort of controlling and animating sprites and a background in a 2D scrolling world.
Perhaps, yeah. But to do it with regular text just means a whole lot of other people think they can make video games now.
Yeah, well, I'm not really sure if it's a text to image generation model. So you're right there.
Yeah.
And, but I don't know. I'm not really that much of a video game guy to think that this is something I want to look at.
No, but I also like the idea of just generating animations. Of course, we just recently had the announcement of OpenAI Sora, which was more like 30-second generated video. Like clearly we're on a path of exploring more capabilities with generative AI.
Yes, we are.
Fun.
So anyway, that's what I got. Know it, learn it, love it. Who's talking to us? Richard Campbell?
Hey, I grabbed a comment off of show 1831, the one we did with Steve back in February of last year, 23, when we talked about clean architecture, because he's a clean kind of guy.
Yeah.
And Ken had this comment about a year ago. He said, this is a great episode, but what about NuGet hell? I love the idea of putting things into NuGet packages, but I can see it will get out of hand as well. Only if you update them, Ken.
Right.
As long as you just leave it with the original bugs, everything will be fine. An example is ASP.versioning. It's a great ASP.NET versioning package, but the NuGet libraries have changed. So now the developers could be making a bunch of changes to the new NuGet packages, which they did 2 months ago, and then other developers would never get the new changes. Nothing against NuGet, but it seems like anything you do in this monster programming world is not perfect. Yeah, no, true. It's just a question of how difficult, right?
Yeah.
And in the area of testing, because we talked about testing on that show too, the world changes and developers still need to learn on the fly. Who is testing my Cobalt world that I was running back in 94 or inherited Delphi from in 1990 or that 4.6.2? And he says in 2000, which, wasn't 2000, it was like 2014, 2015. What about the C++ code in the 90s? What testing framework should I use? XUnit? What about Java? I don't know. Testing frameworks for everything, Ken.
Mm-hmm.
Case in point, in the enterprise world, none of the programming world is perfect. I would include programming training as that as well. But without you guys doing this show, I'd be way more lost. So thanks.
Wow, cool.
That was very kind.
Yeah, it's very kind.
Thanks, Ken. Yeah, no, I think it's an interesting problem. And, often these tools become an issue primarily because they've been successful. If nobody was using NuGet, it'd work great.
I remember in the early days of NuGet, there was such a thing as NuGet hell, quite literally. And it was very hard to manage, just as it was to manage without NuGet. But then they quickly fixed things up, and ever since it's been really great, I think.
Yeah.
I think NuGet's amazing.
Package managers always have their challenges. Like, that's not going to go away.
Especially with Visual Studio tooling, you can just update everything, which can be a problem also, but at least you'll know which ones are the problem.
Well, inevitably, you'll know the most important thing, which is it is your fault.
Yeah, of course. Yeah. I blame you.
All right, Ken. Thanks for your comment, and a copy of Music to Code By is on its way to you. And if you'd like a copy of Music to Code By, write a comment on the website at .netrocks.com or on the Facebooks. We publish every show there. And if you comment there and are reading the show, we'll send you a copy of Music to Code By.
And you can follow us on the Twitters or the X's or whatever the hell it is today, but that's all cool. But we've been there for a long time. The cool kids are hanging out on Mastodon. I'm at Carl Franklin at Tech Hub Social.
And I'm Rich Campbell at mastodon.social.
And send us a toot. And for all the ways you can contact me anyway, you can find that at carlfranklin.com. All right, let's get into this conversation with Steve Smith. We'll bring him back. I probably don't need to introduce him, but I will anyway. Steve, otherwise known as Ardalis on all the social networks, is an entrepreneur and software developer with a passion for building quality software as effectively as possible. He provides mentoring and training workshops for teams with the desire to improve. Steve has been recognized as a Microsoft MVP for over 10 consecutive years and is a frequent speaker at software developer conferences and events. He enjoys helping others write maintainable, testable applications using Microsoft's developer tools. Steve has just published a Zero to Hero course on modular monoliths at dometrain.com, and you can connect with him at steve@ardalis.com. Welcome back, Steve.
Hey, Carl. Hey, Richard. How's it going?
All is well, friend.
Well, I'm not in Mexico, so I don't know where you are, Steve, but...
Yeah, Richard and I were just talking that it's the same temperature in Mexico and Ohio. It's 28 degrees.
Yeah, right.
Ah, okay.
One is
Celsius and one is Fahrenheit.
Something like that, yeah. I like mine better.
Yeah.
Just saying.
Right. So we recently did a show on the monolith, the modular monolith.
Yeah, Layla Porter.
But yep, that's right, with Layla. But it was not really .NET centric, and we thought we'd bring you back to give us the .NET developer's perspective on modular monoliths. So what have you been thinking about, buddy?
Well, the focus of the industry for the last 5 or maybe 10 years even has been on microservices and how microservices are the end-all be-all. And what I've found is that a lot of teams take their existing monolithic code that usually doesn't have a lot of modularity to it. Generally everything is kind of in a big ball of mud, and they don't know what to do to fix that, and it keeps getting worse over time. And so, microservices is right there as this shiny new toy that, if nothing else, will improve their resume. And they're like, if we had these separate microservices, they couldn't possibly be tightly coupled with one another because they're supposed to be independent. So they convince their boss, their job, whatever, that's the way to go. As a means of, following the buzz and getting the other benefits of microservices, like, independence and, separate scalability of individual services.
So I got a question. How does Giant Ball of Mud 1 talk to Giant Ball of Mud 2? Because that seems to be the fundamental problem, doesn't it?
That can be an issue between microservices, yes. But it's like this fundamental thing where the teams I've seen, not my clients necessarily, but just like social media and folks I talk to at conferences, like almost to every one of them, they are thinking that moving to the microservice approach solves the problem of lack of modularity in their monolith.
Right.
And if you do it right, it certainly does, but it introduces a whole lot of additional problems because now you're dealing with a distributed application.
Yeah. And,
rather than trying to figure out how to introduce modularity into your code and become experts at, building and operating a distributed application, like maybe you could just do those one step at a time.
Yeah.
and avoid the possibility of building a distributed monolith, which is what you get, Carl, if you have, these two different things that are actually talking to each other as if they were still in process.
Right.
But now they're distributed.
Yeah, exactly. And
I don't know. He seems a little sarcastic. I'm just saying.
I had a problem. I used microservices, and now I have multiple problems that can't talk to each other.
Yeah. There's an image out there. I saw a meme that's, the poo emoji. And it's like, before I had my big monolith and a giant poo emoji, and now I've got microservices, dozen poo emojis.
Yeah, it just multiply. Yeah.
But this seems like, once upon a time it was service-oriented architectures, right? Like the thing that microservices was going to fix. Like, are we just going through an oscillation here?
Yeah. I mean, microservices grew out of that.
The thing is it's not a bad pattern, right? I mean, to basically a single responsibility idea among different silos. But then, you can take that, you can do that all within a single project and still have separation and still only update one DLL at a time if you're using DLLs, but one little bit of it at a time. And still get all the benefits of that, but without the complexity of this huge distributed mess.
That's right.
That a lot of people don't understand.
There's a bunch of reasons why folks move toward microservices, and some of it's because they want that independent scalability. Some of it's because they see that the Amazons and Netflixes and whatever are using it, and folks say, hey, if that big successful company is using this pattern, I have to use that pattern so I can become big and successful. It's like, that's not really how it works.
And you ask them, how many customers do you have? Oh, 100, 200. Yeah. Okay.
Yeah. Do you need infinite scale on your, one feature of your application? Maybe not.
Yeah.
So, there's that issue. And distributed applications are much harder, right? Like, Martin Fowler's got an article from 2014 that basically says if you're trying to build a microservices application, instead of building microservices first, build a monolith first, figure out how the design works, and then, split off individual microservices as and when and if it makes sense to do so.
Right.
And that's much less risky. There's fewer dragons. He's got an image with dragons.
Well, this sounds exactly like the usual scaling issues, right? It's like, well, we've got to build the site scalable. It's like, well, what parts need to be scaled?
Right.
Yeah. And sometimes for, medium-sized to large organizations, part of what they need to scale is their teams, right? They've got an application that's so big that they're trying to put multiple teams working on it, and they're running into a Conway's Law problem, and they're hoping to fix that with microservices. But you can build modular monoliths and have multiple teams collaborating just fine also. It's just a matter of how you structure your solution and break those things up.
Yep.
Well, I think that's something that Layla brought up as well, which is like Conway's Law certainly applies to microservices and the idea being that all software reflects the team that's built it. So it's like if you're building an app with 3 different teams, you're going to have 3 feature sets.
Right.
So, one of her points was, unless you've got a team that large, why would you bother with microservices? Because they really come down to granular elements that can be worked on simultaneously, hopefully.
Right.
So if it's only 6 people working on the thing in the first place, you're really creating a lot of plumbing for no good reason.
Yeah, it does.
If you're building this modular monolith and you do determine that, there is a bottleneck in one of your projects or, one of your silos, you should probably know how to be ready to carve that off into its own service and communicate with it, not in process, but, through some other mechanism, whether it's APIs or gRPC or however. So it's beneficial to you to figure that out and be at the ready to either generate the code around that, or be able to do that and have experience with it before it becomes a problem. Don't you think?
For sure. Yeah. And so in my course that I just finished, the starting point for most monoliths is a single project, right? File, new, whatever, console, ASP.NET Core, and that you almost always have to start with a monolith in anything you're building. And in a typical, just monolithic application, it just never splits from there, right? It just grows and grows and grows. And, whether you're using MVC or Razor Pages or whatever it might be in the .NET world, like you just keep adding them to that same project and it just keeps getting bigger. And if you have separation, like if you're following clean architecture and you have multiple projects, they aren't split vertically. They're not split per feature. They're split per technical concern, right?
Mm-hmm.
I love clean architecture. We've talked about it here before. It's a great way to keep your domain model from becoming tightly coupled to your database. But when you only have, primary projects of user interface, all your infrastructure concerns, and your domain model, you don't have any type of separation vertically between, like, here's the products feature, and here's the orders feature, and here's the customers feature, right? And then all those things can talk to each other, and so they do. And that's what makes it a tangled mess at the domain model level, at the UI level, and all the way into the data model. It becomes very difficult to carve those out into a separate service that you'd want to split out for whatever reason, because of performance or maybe security or data isolation. There's all kinds of reasons why you might want to split part of that out. And it's hard to do that if you don't have a plan for that going in.
I remember Yuval Lowy talking about areas of resonance. Basically the idea is that if I make a change here, does the whole app resonate with the change? Like, you have to go check for impacts everywhere. Or if I make a change in this particular spot, is everything directly related to that the only thing that resonates? If you're messing with payment systems, only payment system stuff is affected.
Right. Yeah, I was in the military, so I use the term blast radius. And,
I use that after a good meal.
When I break this, what all is in the blast radius that I'm going to have to fix?
What's in the blast radius? I usually measure the quality of my meals that way. But
that's what I just said, yeah. But I think that was your joke originally, Richard. Deference to you.
No. I think the ex-military guy using blast radius has a whole other impact than I do, without a doubt.
But yeah, the idea obviously is to limit the blast radius of certain types of changes, right? If it's something that should only affect, like, how orders are processed, then you would hope that making that change doesn't require you to redeploy everything that has to do with, customers or, the search engine of the site or whatever it might be.
Mm-hmm. Well, I'm just thinking in terms of merge conflicts, man. Like, yeah, okay, he was busy working over on payments here, and then somebody went and made some changes to product, and now I have a merge conflict? Really? Like, that shouldn't happen.
Right.
But you also have the problem of interactivity between all your projects, right? So one project might have references to 2 or 3 or 4 other projects. Mm-hmm. So now if that one project needs to go into a microservice, what do you do with the other ones? Are you now committed to splitting everything up? And that just increases complexity.
Right. Yeah. Well, even adding the modularity increases complexity of the whole solution. But the point of it, or one of the points of it, especially if you have a large team and you're hoping that you can have different teams take on different modules, is that things become simpler in that module. So if you look at the whole solution, like your 4-project solution now has 15 projects because you've broken it up into 4 modules. Right. But when you're working on just the order processing module, you still only care about, 2 projects, and you don't care about all the other modules. So your actual area of concern on a day-to-day basis is simpler.
True. Everybody has that shared project, right? Where all the things go, like models and all of those things.
Yeah, oftentimes, yes. And it might be shared or it might be per module, right? You'll probably have both. You'll have some that are global and some that are per module. But like, this is just a pattern. Like, the modular monolith is a pattern. It's not a totally prescriptive thing. But the way I have built it and the way I show it to do in my course is to have a single entry point host process or project. And so that's my ASP.NET Core project that enters in. And it literally has nothing in it except program.cs and appsettings.json. And its job is to load the modules from the other projects. And then a given module in the solution is basically just a solution folder, because we don't have better artifacts for that in .NET world, at least at the moment. And inside of that solution folder, there's 2 or 3 additional projects, right? There's the actual code for the module, which includes all of its UI and all of the domain model logic and however it talks to a database, and then, all the logic for it is in there. And they're separated just in folders, right? There's not, it's not a clean architecture thing with separate projects in there. All those different pieces are there, but they're just separated by folders. And the reason is that I want them all to be internal. I don't want other modules to be able to access those at compile time. So I'm using the internal keyword heavily anywhere I can to keep that module locked down and encapsulated. And then another project it'll have is tests, because I like tests. Now, how do the tests work against that project? Well, we can use the internals visible to attribute on the assembly to make it so the tests at least can get to those files.
We encourage everybody listening to pause and rewind and listen at half speed because you just unloaded a whole bunch of pile of wisdom there, Steve.
Yeah, sorry.
That you might want to listen to a little slower, but by all means continue at this pace because I think it's great.
That's a consequence of listening to YouTube and podcasts at 1.5 speed. Is I think like this is how people are supposed to talk. Is like this fast all the time.
Yeah.
But yeah, sorry.
But I mean, just a whole bunch of stuff you just gave us advice to do, using internal and the way that projects are scoped and solutions are scoped. So yeah, there's a lot to it. And it's a lot, as we're obviously figuring out right now, it's a lot more complex than people think, even in a monolith, to be prepared to go.
Yeah. I mean, to set it up,
out.
to give it the initial structure, there is a little bit more complexity, a little bit more work. It's really not that bad. And probably like I've done with clean architecture, I've published a template that you can install off of NuGet that's on GitHub. And you can just do a, .NET new clean arc and it gives you the solution all set up. I'll probably do something similar for modular monoliths. I just haven't gotten there yet.
Yeah.
But once you have it set up, like adding another module is pretty straightforward. It's like add a solution folder, add these 2 or 3 projects, and you're off and running. The third project that's typically in that module that I haven't mentioned is a contracts project. And the whole idea of the contracts project is that's where the shared stuff goes. That's where the DTOs or the messages or things that you need in order to communicate with that module from another module, where those would live.
That's great. Yeah, very important. Just really quick, I don't mean to change the subject because we got to get back to this, but what's DomeTrain and why haven't I heard about it?
DomeTrain is Nick Chapsis's training company. And so Nick Chapsis is a real popular YouTuber, talks about .NET a couple times a week. And so he has initially published his own courses, but in the last year or so, he's brought in a bunch of additional authors on there. And so you'll find my modular monolith course there, as well as a bunch of other courses. And I still have a relationship with Pluralsight, and I have a bunch of courses on Pluralsight as well, but I'm trying DomeTrain out for the modular monolith topic.
Cool. Because I think that's, people are like, okay, you convinced me. I want to go check out this workshop here. Great stuff.
Yeah, and I don't know if it'll still be good when people listen to this show, because I know that could be in the far future, but at least for now, if they use Ardalis when they check out one of those courses, they get 20% off.
Nice.
Very good.
So when you were talking about contracts, you're not talking about contracts as in something that's a part of the domain for this business, but contracts as in the contracts between elements of the application,
interfaces, etc.
Exactly. Yes. Not contracts like legal contracts, but the public messages. They're classes, they're records, they're DTOs. They could be queries, they could be events, they could be commands. Those are typically the 3 types of messages that your application will use. And then you will have DTOs that represent the actual things in your domain.
Right.
Yeah.
And so that's just basically a way to maintain that reliability from update to update.
Yes.
The old DTOs are still supported. So that we did a lot of this with the old in service bus approaches, just because I had so many different teams working and in different languages. So, there's no way you're going to get everybody to move to V2. Like it just wasn't a thing.
Right. You have backward compatibility.
Yeah. The bigger celebration was when did you get to retire a contract, if ever.
Yeah. And the other key reason why that separate project exists is to touch on what Carl was mentioning, which is, what if these 2 things need to talk to each other?
Right.
Not just in one direction, right? So in .NET, as soon as you split out 2 things into 2 different projects, let's say we've got customers and orders, right? And so I want to go and get a customer with all their orders for this page I need to show. Okay, well, then I guess customer needs to have a reference to orders so it can go get all the order stuff. All right. Well, now I'm on an order, but I want to show all the customer details with it, right? Well, okay. Well, now that order endpoint needs to have some way to go call customer. Well, as soon as you try and add a project reference in both directions in Visual Studio, it's not going to let you. Circular references aren't allowed. But you could certainly have the customers module depend on order.contracts, and you could have the orders module depend on customer.contracts, and that's perfectly fine. And then you can use those messages to communicate with one another.
So, one of the byproducts of splitting up all these silos into individual things when they're distributed is it's almost like the SQL join problem, right?
Right.
When you follow Dr. Cod and everything's in like all these fully normalized tables, and then just to pull one set of data out of the database requires 14 joins. I mean, you have the same kind of thing here, right? With microservices, if they're too complex. And so walking that line between, what's the granularity that we need?
Right. And that is tough. And if you get it wrong with microservices, it is fairly expensive, but mostly in terms of time and effort, sometimes actual money, to refactor a distributed application in order to fix something like that, where like these two concepts really should have been together, but we split them and now everything is harder.
Yep.
Yeah. Now we're being punished for it. I mean, we got to have a whole conversation just about debugging microservices in the first place, because that's hard to.
Yeah.
Yeah. The beauty of the modular monolith approach is that you're not distributed. All these communications that we're talking about, they're all in process. Right? You can use a tool like Mediator and the Mediator pattern to make it so that one module can talk to another just by using those contracts. You can new up a command and say, mediator.send this command, and some other module that knows about that command is the one that's going to process the work. And if you're stepping through in a debugger, you just step right from module to module. Everything just works in process. It's fast, right? There's not a distributed message bus or anything involved unless you need one. But just, by default, your monolith, which is now a modulith, if you will, a modular monolith, is still what it was before, right? It's still simple to deploy, simple to debug, all runs in one process. Just all we've done is logically separate things into these different modules.
Mm-hmm.
But Steve, what about Kubernetes?
You never have to worry about it with this approach. That's the beauty of it. I think Kubernetes is a way for cloud vendors to make more money.
Well, it's working. But I mean, it's just an interesting point about this, that the deployment or the implementation and the architecture are separate things. You certainly can push out a monolith in a container just as well as you could push out a set of microservices in container.
We have a friend who listens to the show, and he knows who he is if he's listening, who I'm friends with, and I've been friends with him for a long time. And his boss, at his company, is sold on, Kubernetes and microservices and all these things, and the domain-driven design and all the things that go with it. And when you talk to them, it's like they only have a handful of customers, but so it doesn't make sense. And he can't talk any sense into his boss in terms of, trying to simplify this and going monolithically modular. And it's just painful. It's very painful. And, I guess, as you said, I think it might be a little bit hubris. Like, oh, well, we need to anticipate the day when when we suddenly have millions of customers and blah, blah, blah. But you really need to ask yourself, is that going to happen? And can we prepare for it now and serve those 500,000, 10,000 customers, serve them well, and be ready for the next for 100,000 customers?
Right. And there are challenges even with this architecture, right? What is one of the nicest, easiest things you get out of a monolithic architecture is that typically you have a single database and anybody can query that database for anything they want at any time from anywhere, right? And that's a blessing and a curse, right? Because it means later on, if you do decide to try and split this up into different modules or microservices, like that is usually one of the hardest things to do, because you look at your database and you're like, hey, let's create an entity relationship diagram and see all the foreign keys. And it's just tangled web. It's like, well, everything is related to everything. How do I start? And it's easier to just write a query with a bunch of joins in that scenario. If you move to microservices, every microservice should have its own database. If you move to a modular monolith, the same is true. Although typically you can just use schema, not the whole SQL schema, but the schema type in SQL Server or a database, so that every table is prefixed by the schema. So you'll have orders dot order and orders dot order item, for example. And then you just make it a rule that you follow as a team that when I'm in the orders module, I only work with things that are in the orders schema. I don't go reach out and find other things that are in the database.
Right.
But you can if you want to, and that's one nice thing is you got that escape valve if you need it. But there are other patterns that you can use when you need data aggregation. Like, I really want to run this report, and I'd like to be able to join across the orders and the customers and the addresses and the products. And, that is difficult to do in a microservices scenario where you've got 4 different separate databases that might even be running on different database technologies. But there are patterns that you can use to make that happen. And I show how to do that in my course also.
Mm-hmm. Mm-hmm.
Hey guys, let's take a break. We'll be right back after these very important messages. And we're back. You're listening to .NET Rocks. I'm Carl Franklin. That's my friend Richard Campbell in
Howdy.
Mexico somewhere where it's nice and warm and sunny. God damn it.
Nice and warm and full of palm trees, yes.
And that's Steve Smith. And we're talking about modular monoliths. And Richard made a joke. But what about Kubernetes? And, it's kind of bittersweet because a lot of people use it and a lot of people are very good at it. But eventually, if your modular monolith does become a set of microservices, it's not that Kubernetes is going away, right? It's just that, we don't want to start with it.
Right. And I mean, the main thing you get with Kubernetes is managing all these different services in a way that allows for independence and independent scale. Yeah. And in your monolith, initially, you can still scale that, right? Like, even if you're just using a simple app service or you're hosting your own VMs or whatever, right? You can always have more instances of that and scale, horizontally that way. Not to mention vertically. I mean, you can add, more horsepower to that instance for quite a while.
Mm-hmm. Especially if you're playing in cloud land.
Yeah.
The cloud land machines are just getting more and more powerful. So
right.
You don't have to distribute across multiple instances.
Yeah. You just spin up the dial and say, well, I need 10 of these if need be for horizontal. Or you spin up the dial and say, well, I need an E or an F or whatever labels they have for the higher.
There'll be a Q one of these days.
Yeah. That'll be the quantum computers.
There you go.
But Stack Overflow is not using microservices, right? I mean, if you ever read anything about their architecture, they just have some really powerful servers that run the entire site. Mm-hmm. And most of our apps we're building don't have anywhere near the traffic of Stack Overflow or the response time for that matter.
Right.
Yeah. So, I mean, there is some software side of this. What I appreciate about containers is not just that mechanism of scaling, and they're relatively small, but it's also a unit of update. Like, containers give you a habit of treating software like cattle, not pets, where you don't modify anything. You just make a new one.
All our Indian listeners just shuddered in horror when you called them cattle because those are sacred.
Okay,
what do you mean cattle?
I didn't say what kind of animal.
Okay, yeah. No, it's a good metaphor for us.
The point being that you tend not to update and create unique states. That you design. The update is a new manifest. The manifest creates new instances of containers. If you want to manage them in Kubernetes, knock yourself out, whatever makes you happy. And then you shift workloads over to the new implementation and the old ones can be shut down.
Yeah.
Right. That's the magic of cloud, right? That you don't have to update servers anymore. You just make new ones.
Right.
And kill the old ones.
Right. And the beauty of ASP.NET Core, it works with Linux. It works, cross platform. So you could certainly take this modular monolith deployable, the DLLs that you're going to deploy, and send that into a Docker image and then host that container. And then as part of your CI/CD pipeline, publish a new container, push that up there, have a blue-green deployment or, whatever you want to do. And when you've vetted it and verified that it's good to go, replace the existing one with that one or with 10 of that one, if that's how you want to scale.
Yep.
And you don't necessarily need to have microservices. But let's say you do, right? Let's say that you've got this modular monolith that you've built and it's, been easier to build along the way because you didn't have to deal with Kubernetes yet. You didn't have all the, distributed application effort yet. And now you realize this piece, this one module really needs to be separate for reasons.
Because it's a bottleneck in some way. It's a performance bottleneck or a feature bottleneck. Like, what is it?
It could be any of those things, right? It could be that it's a bottleneck. It could be there's a different team that's in a different time zone that you want to work on it. It could be, there's GDPR requirements that the data can't leave Germany, so you need to host it somewhere else. Any number of reasons, right? Well, if it's been built as a module, it's fairly easy for you to pull that out and put it in a separate process.
Right.
And now, that can be you're not necessarily on a microservices architecture, but you do have, now one module that's separate from the rest of your modules that are all bundled together. And so you take the logical separation that you already have and you turn it into physical separation on a case-by-case basis.
Right.
You don't have to, do all of it at once.
But this isn't free either. You're adding an authentication layer there then, and a transport layer, because it's not part of the same thing.
For sure. Yeah. There's a host of things that you'll have to figure out, at least for that first one. Like, how are you going to communicate it with it now that it's out of process? And the nice thing about the modular monolith approach is if you're using messages like I've described, this contracts approach, is those messages all have handlers that in a monolith can just do the work, right? In the handler, it goes and makes a database call and gets the stuff it needs and returns back your DTO, and that's that, right? Now you suddenly say, well, actually, you're across the wire from me. You're somewhere else. And so you can't just do that anymore, right? Now you've got to transport it over a message queue or a message bus. You've got in-service bus in between, or there's an API layer between, and we have to have, token-based security flow all the way through. Like, all of those things can still be done. Just in that handler now, you're going to add that additional work, probably as a decorator, as another handler that sits in front of that one, so that the original one doesn't even necessarily have to change, but you'll add that new responsibility in its own class that sits in front of the existing one.
Okay. Yeah, that makes sense. But I also appreciate the idea of, like, you only do this because you need to. You're adding complexity and overhead and impacting performance, I would think, too, a little to some degree.
Yes.
But, as a guy who's done a lot of scaling over the years, it's like, I'm going to reduce the single use performance so the multi-use performance stays consistent.
That's
Not necessarily fast per se, but at least as the number of instances go up, it doesn't change. Because that's the only thing that makes people sad, is that this one took 5 minutes where the other one took 4 seconds.
Yeah.
Right. Yeah. Just trading for scalability will almost always make individual performance worse.
Right.
Because if you just have your entire application on one box and either it doesn't have a database or that database is also on that box, right, then all of your calls are on the same box, right? There is no network hop. And so you're going to come back in, milliseconds, very, very small milliseconds on every request. But how do you scale that? Well, that's the trick, right?
Tricky.
And so as soon as you start scaling it and you have multiple servers involved and network hops, everything is orders of magnitude slower, but still generally fast enough. And now it scales, linearly, at least up to some point.
Yeah. Nothing's for forever, but it should be enough at least.
Right. And in architecture, everything is a trade-off. So it's just a question of what is the right architecture for your application for today and for the next, whatever period of time you anticipate needing it.
Yeah, for a sufficient amount of time.
All right, Steve, here's a scenario for you. So people are listening to this and they're about to embark on a new project and realizing that they're going to get in over their heads in the upfront architecture if they're going to make this right. Maybe they've watched your workshop here, your course, and they want to hire a consultant, right? So they bring in these consultants, and as we know, consultants, many of them can talk a great talk, and they're on the lookout for smells, right? Mm-hmm. So what smells should we be looking out for when we're hiring a consultant and they sit down and they say, all right, here's what I think you should do, blah, blah, blah. What are the smells that say, nope, this guy does not understand?
Well, first you should just call Nimble Pros, because that's us, and we can help you. Right. So go to nimblepros.com. Plug that you set me up for. Sorry, but no, if you're looking for things to watch out for in your in your monolith or in your architecture, the biggest thing, if you're hoping to have modularity, right, whether it's microservices or modules within a monolith, the thing that will kill modularity is things that will kill independence, right? Things that add tight coupling between modules. So if it's microservices or modules, if they're sharing the same database, that's a red flag. That's a code smell. And I mean the actual tables in that database. If they have separate schema and they're on the same database server, that's fine. And you can always break that apart later. But if they're literally just sharing one data model between multiple modules or microservices, then that's going to make them tightly coupled, and you're going to lose that.
So if the consultant says, so here's module 1, it's going to talk to our central database, and module 2 and 3 are also going to talk to our central database, you say, there's the door.
You ask them a question of, hey, doesn't that make them less independent from one another? And then you hope they have a good answer. Like maybe there's a good reason why they don't want to split the data model.
Right. I was going to say,
That is complicated, or it does add complexity to split the data model.
And there is such a thing, as we know, as too much separation, right?
For sure. Yeah.
So I guess, yeah.
Right. Like, Michelle, my wife and partner at Nimble Pros, is a veterinarian by education, and they kind of have a thing where they don't talk badly about how another veterinarian diagnosed something. Right. If somebody comes in and they took it to another clinic and then they bring it to you, like, you don't know what that vet saw. You don't know what the animal was doing at that time. So I'm not going to talk badly about some consultant or architect or whatever that makes certain decisions, because I don't know what they were thinking, what they were seeing at that moment, and how the requirements were given to them. I will only assess it based on the information that I get at the point in time where I am introduced to the problem.
So maybe if I could throw in an answer here, if you hear them say always or never, only a Sith speaks in absolutes.
That's right. Yeah. Try and be practical and remember that everything is a trade-off.
Right.
If
they say it depends,
the other side
lot,
of this is always saying it depends gets old too.
It's true.
It only is helpful to say it depends if you immediately follow that with what it depends on, and how your decision will be different based on that.
Yep.
Again, in a healthcare field, if you're diagnosing something and you say, what's the treatment going to be? And you say, well, it depends.
And then walk away.
Everybody is waiting on what? On your test results. It depends on the test results. And then, based on that, we'll do X or Y. Like, that's the answer they should get.
Mic drop.
Yeah.
Sure. All right. So anything else that the type of
other red flags for sure would be direct calls between modules, right? And direct, I mean that they are, on a modular monolith, you can get away with synchronous communication using the mediator pattern. And I show that in my course, and it works fantastic. Mm-hmm. And the reason why that is allowed, in my opinion, and why that works in a modular monolith and it doesn't work in microservices, and what I'm describing is in microservices, if you have a direct synchronous call from microservice A to microservice B using gRPC or web APIs or whatever you want, that means that they both have to be up at the same time. Mm-hmm. And so now they have a dependency that, they are not independent. If one goes down, the other goes down. And so if you want to have availability of these services, even when one of them is down, one of them is being updated or one of them crashed or whatever, right? Then you can't have those direct synchronous dependencies between them.
So you want to use some kind of message queue or service bus or something like that. Yeah.
Exactly. Right. So for commands, you can usually get away with just throwing a command on a queue. And then when that other service gets around to it, it does the work. But for queries, you usually have a conundrum, a different problem. Like, I need this data from that other service. How do I get it? And so for that, the easiest approach is data duplication, right? You have a cache, and that's called the materialized view pattern. And I cover that in my course also. But the general idea is that instead of you asking service B for its data with a query over the network, you just get the data out of your own local copy of service B's data. And service B is updating that copy constantly with events. Right. So every time there's a new record added or removed or updated, an event is fired and you update your cache. And so if that other service is down or communication between you is down, you always still have your cache to work from.
Data might be old.
No idea. Right. But the data might not be up to date. Exactly. So it's the CAP theorem. You're trading consistency for availability.
Right. And what about CQRS? That comes to mind, where you have a separate pathway for querying than you do for writing data.
Right. And it's exactly this type of thing I just described that is one of the reasons why you want to have that separation of commands and queries. Right. So CQRS, if people don't know, the acronym is Command Query Responsibility Segregation. And the benefit of it, there's a bunch of benefits, but one of them is that you can use different patterns and different architectural approaches for your commands versus your queries. So like I was saying, you could throw a command on a queue and forget about it. You can't do that with a query, right? You can't just throw it on a queue and continue on, because you need that data. And so you have other patterns that you use to respond to those. And so in a modular architecture, whether it's going to turn into microservices or remain a modular monolith, it does make sense for you to define your messages in terms of queries and commands and events. Right? Those are the three messages you should have explicitly defined, and then use those as your mechanism for communication, and then put those in the contracts project for each module.
And just to illustrate how complex these things are, I saw a great tweet by Greg Young, who was the first one to do CQRS. I think he might even coined the term in the pattern, but that he was turned down at a job offer because they said he didn't know enough about CQRS. You don't know anything about CQRS. It's like saying, Steve Smith, you don't know anything about Nimble Pros. Go away.
Yeah, like did you even Google it?
Yeah.
Google that phrase and his name, right?
So what have we missed? Is there anything else that people should be on the lookout for? Maybe when investigating an existing architecture, right? And you obviously things that are tightly coupled, but how does one begin to take a monolith that might not be modular and modularize it?
There's a few different ways that you can start. Like one of them is you look at the data model or the object model and you try and figure out where there's some isolation. There's some things that could stand alone. And it might be that your hand is forced. It might be that there are constraints, like this is the one that's not performing well enough, or this is the one that needs to be in a separate region. And so you have to start there. But if you're not forced, it's usually best if you can pick something that's low-hanging fruit that is, sort of the hello world of the various modules, right? Something easy. And so, sometimes it's something like how we send emails, right? Take all the email sending functions and put them in a module and figure out a way to send communication to that module to say, hey, here's everything you need to send this email. And then it can do that work, right? And that could also be spun off as a microservice if you want it. I've done that many times for clients as their first microservice. Like, here's your microservice that just sends emails. Like it's really small. It's micro. It's only got one thing it has to worry about. And you do it from all over the place inside your various applications. So like it makes a good first microservice. And then likewise is an easy thing to pull out, some type of thing like that, could be an easy thing to pull out for a module in a modular monolith. The reason for it is that once you've done something simple and easy like that, you've figured out where all the dragons are. You figured out what all the problems are. It's a nice, easy vertical slice that, you have to answer all those questions. Like, well, how do I communicate with it? And how do I, separate it? And how do I deploy it separately if it's a microservice? All those questions have to be answered, but you're not, bogged down by like, this is this huge, massive, complicated thing that's tied into everything else. Like, no, do a simple thing that you can solve all the distributed problems or all the modularity problems. And then once you have that as an example, now you can just take that example and use that same approach for the next one that's more challenging.
Do we have to know DDD in order to do this? Do I have to take a course on domain-driven design?
You don't have to, but it probably helps because of some of the patterns that are involved.
Right.
Each one of these modules or each microservice should be its own bounded context.
Right.
And if you have never heard of that, then
that's a DDD
learning
term.
A little bit about DDD would probably go a long way.
Right. Okay. So, I'm basically hearing of voices of the listeners out there going, all right, you guys are sort of pooping on microservices, but does that mean all these other technologies and patterns and strategies that we use are invalid? And, the answer over and over again is no. It's just that the modules exist in a single project first.
Right. Yeah.
Or a single solution.
If there's a good reason to go to microservices, by all means, I'm not saying don't do that. I'm just saying don't do it without a good reason, right? And don't necessarily do it out of the gate. Like,
yes.
If you're building a brand new application, you will go orders of magnitude faster building a modular monolith than you will if you're having to try and be a bunch of different services that all communicate to each other. Like debugging and deploying and reckoning with that and then changing that design later.
Yeah, that's the thing.
Wrong.
You'd be less likely to get
so
stuck.
Expensive. Yeah.
I mean, the only place I've seen this make sense, and we addressed this before, is we have 100 people working on this, and they're actually breaking it into these pieces and creating all those communication layers because it allows everybody to work at once. And hopefully, and you've got a contract team that's sitting over top of that that's making sure that the APIs are consistent so nobody gets surprised. So you're already paying the overhead to make that many people productive.
Right.
I just don't know how many folks are in that situation. Right? Like really, there's an upside to Conway's law, which is if the app is architected to the size of the team generally has their hands around it. Like they know what they're looking at.
Right. Yeah.
And this subsequent, breaking apart of things because of performance or other constraints is more reflective of how the software is being used rather than the initial architecture.
Yeah. And why do you have 100 people working on this? Usually it's because you want to achieve some level of velocity. Right. Well, I would argue that you could have half as many people working on it and, build it as a single repository, modular monolith, and you would go faster than having 100 people working on it in a dozen different repositories and all trying to figure it out with a separate team responsible for contracts and another one responsible for making sure everybody does everything right. And two more teams responsible for figuring out how to deploy it all.
Well, Steve, is there anything else besides your course you want to pitch or talk about, or did we miss anything before we sign off?
I should probably mention, since we've been talking about microservices and monoliths, that I do have another course coming. I think it'll be ready 1st of April or so on from microservices to modular monoliths, which is the backward direction from most of the books and literature that's been around for the last 10 years. But if you found yourself in a mess with your microservices and you want to get back to a monolith, but still keep your modularity that you've worked so hard to get, that's what this course will cover.
Very cool. Steve, I can't thank you enough for being with us. It's always enlightening to talk to you, and we always learn something. And take the course. Get out there. Check it out. Thanks again, Steve.
Thanks, Carl and Richard.
All right.
Always fun.
We'll see you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Plop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and, of course, in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got a transmitter band by the FCC.